to find my notes so I don't actually have to do all this.
Did you go shopping?
I did go shopping on Thanksgiving night.
Me too. It was so fun.
It was so great because they opened so early. Like I got home.
Wait, you like that?
I went out. I left my house at like 6, and I got home by midnight. And
I left at 7, but we didn't get back till 4.
okay, so some of these we can do pretty easily, but by the time you get up to like x plus y to the 4th power, that's a lot of work. The binomial theorem is supposed to be a way that we can expand binomials maybe a little quicker. Obviously, the higher the powers, it's still going to be some work. But think about if you, I don't know why I said let's look at n equals 1, 2, 3. I should say 0, 1, 2, 3. 0. What's anything to the 0 power? So x plus y to the 0, it's just 1. X plus y to the 1st power, that's simple, right? It's just x plus 1. I'm not actually going to show all this, you just need to trust me, alright? But x plus y squared is not just x squared plus y squared. Remember, you have to FOIL it. There's a middle term. So you would get x squared plus xy is plus 2xy, and then plus y squared. That's our lovely FOIL that you've been learning for a while. Then it gets a little uglier. X plus y to the 3rd, you have to then take this whole thing times x plus y again and distribute it all. And I'm just going to tell you that it is x cubed plus 3x squared y plus 3xy squared plus y to the 3rd. And that's just if you FOIL it all out and you combine like terms, that's what you would end up with. And if you did x plus y to the 4th power, that would be x plus y 4 times, or taking this whole thing times x plus y again and distributing and combining like terms. You would get x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. We're going to do something like the 10th power. Isn't that exciting? Today's the trick. So here's what I want us to notice. A few things about this, and I don't know that it matters in what order we notice. But what do you notice about the number of terms in each one? Yeah, like this was 0 and there's 1 term. This was 1 and there's 2 terms. This is 2 and there's 3 terms. This is 4 and there's actually 5 terms. That's always true. There will always be n plus 1 terms. Whatever the exponent is, you always have 1 more term than that. So the 10th power, you'd have 11 terms. What do you notice about the exponents on the letters? That doesn't mean anything. 4, 3, 2, 2, 3, 2. That doesn't tell me. That's not.
It was like big and then little and big.
As it goes on, x gets smaller, yes?
Yeah.
And as x gets smaller, the exponent on y gets bigger. What do you notice about the sum of those exponents?
They always equal.
You notice that the sum of each term always equals the power over there?
4 plus 2 plus 1 is what?
These two. 4, right? What about this? What if you add that up?
Oh,
4.
I see what you're saying.
That's 4, that's 4, that's 4. Like each term adds up. Each one of these adds up to 3. I just wrote as x decreases, y increases. Oh yeah, and that's my last one I said. The degree of each term equals n. Which means it's not that hard to figure out the exponents, right? You start with the n for the x, and x goes down, y goes up. But you got to figure out the number in between, right? That's the hard part, is figuring out the numbers. So there's 2 ways we can do this. One is the binomial theorem. The binomial theorem uses combinations. We just did combinations and permutations in 9-1 that you did last Monday. It seems like a year ago. But a week ago, we did combinations and permutations. And there's a formula for this. It looks kind of ugly, but I think it's important that you write it out, and then we'll talk about what all of it means, okay? I'm good to go. Is everybody okay with that? Oh, that looks terrible, right? Write this down. I didn't even write the date up here. didn't get out of bed until 5:53 because I just hit snooze and then I just turned my alarm off and then I kept getting emails because it's Black Friday and so luckily all the emails that kept coming to my phone woke me up. I know. Sorry, Cyber Monday. I kept getting all the emails about Cyber Monday and woke me back up and then I was like, oh crap, I'm not getting this so early to do the board. So, sorry, Zane. The Monday after Thanksgiving, they just have lots of sales. Like I got 20 emails this morning from all the places I ordered stuff from to tell me that it's Cyber Monday and the great deals I'm missing out on. They say Cyber Monday is a very unproductive day at work for most people because they just set their computer and look at their Cyber Monday deals. But I have to teach you.
I think you just get this Monday.
Wow, maybe I know.
Okay, so we did already talk about the powers, right? We start with x to the n, and we're going to subtract 1 all the way down until there's no x left, right? And so that's what that whole power means. The y, notice there's no y, and then there's 1y, and then there's going to be at the end y to the n. So that's just giving you the exponent part, which I don't even really think about. I just know as x goes down, y goes up.
Let's then see how that.
That's the combination part. So, also notice, let's go back for just a minute, if you look at the term, the second term and the second to last term is always the power here. Kind of weird with n, so let's go back for a second. On the 4, notice this was a 4, this was a 4, notice 3 and 3, notice there's a 2 in the middle, right? So like if you had to the 10th power, I could start right away by knowing, I don't know all of them by heart, but I know it would start with x to the 10th, and then I know it would go 10, x to the 9th, y, right? Because every time the x goes down, the y goes up, and the second term is always the n, and there's going to be a whole bunch of terms in between, and then the second to last term is going to be 10, x, y to the 9th, and then the very last term is going to be y to the 10th. You with me on that? So the hard part is what happens in the middle there. That's where the combination part comes in. We do kind of need that part. That's where this comes in. So if you have more than 4 terms, if you have something higher than the third power, you can't just use those tricks because there's stuff in the middle. How do you figure out what the coefficient is? You can do a combination. So NCR is another way of saying combination in R, right? Like that's how it is on our calculator, which means you can just use the calculator, but it's just a combination formula, which was what, like n factorial over r factorial, n minus r factorial, or I'm going to say, or use your calculator. It's just a combination. Oh, R's, you got to think about what R is. R is what the exponent is on y at any term. You see what I'm saying? Let's do one. How about that? Alright, that sounds like a good plan. Although this is silly first. Why are we doing this? You have a calculator. Anybody else want a calculator? Okay, so let's think about what n and r are. N is always the power, right? The power out here. So like this would be like to the 5th. R is what y is. So if y is to the 3rd on this one, right? This is like y to the 3rd. What would the exponent be on x at this term? Because it has to add up to n every time. You see what I'm saying? So that's sometimes you have to think about what term would that be if I was doing this problem. This one they just want you to give the coefficient, I think. Like I don't even think they even care about that part. Which means you just have that in your calculator and just get 10. That's silly. They should do harder problem than this. think it's just one. It's the very last one. That one's silly to do the thing on. Is it gonna? Oh yeah. I thought I'd throw this in there because the book sometimes does a weird, another way to write a combination. It's the same thing. This is the same as saying 100, choose 98. Or combination 198. So I just threw that in there because I think there might be a couple in the book that write it that way. And again, if you're thinking about the term, this would be y to the 98th power, so what would the x be?
2.
Because it has to add up to 100.
Wait, what are the numbers for again?
10 and 1. What are those numbers?
That would be the coefficient in front of it. So on this term, it would be like 10x squared y to the third. This would be like 1 y to the 20th, because it's the last term. And what happens on this one? Ooh, I bet your calculator says overflow error. Does it say overflow error?
It's not that big of a number.
If you try to do 100 factorial, it will say overflow error.
Yeah, I'll go.
So what does that number represent? That would be the number that goes in front of this. Imagine if I wanted you to take something to the 100th power. Even with doing this shortcut, that's still a terrible amount of work, right? I've never made you do something to the 100th power. All right, you want a shorter cut than this?
Yeah. That was pretty nice. I just need it better.
It can get even better. Let's see. Another way that you can do this, and I will tell you on your homework, even if it says use the binomial theorem, on your test, if I want you to expand it, I won't make you do one or the other. You can choose which one you want. I like Pascal's triangle. It's a really easy way to get the coefficients without having to do the combinations every time. But you got to know what Pascal's triangle is. Pascal's triangle starts with 1, 1, 1, and then here's the rule for Pascal's triangle. The outsides are always 1s. The inside numbers come from the sum of the two above it. So outside numbers are 1, and then 1 plus 1 is 2. And you can just go on forever. And there's a whole lot of stuff that works out with Pascal's triangle, but all we're going to use it for is the coefficient. So I'm going to make a few rows of this so you get the idea of it, and then we'll just stop. But again, a 1, and then what number is going to go here? 1 plus 2 is 3. 2 plus 1 is 3, and there's always a 1 on the outside. 1, and I'm just going to add it up. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 on the outside.
Who's Pascal when you were?
He's a math guy, and he's long time ago. I don't know the dates that he
You
was.
have like a full list.
I got nothing. I'll look something up for you.
So his name, Pascal.
Pascal.
Louis Pascal.
So for the middle ones, I would say 4 plus 1 is 5, 4 plus 6 plus 4.
Just two. Just the two. So then 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and then another 1 on the outside. And it just keeps on going, right? Here's what's really cool. These are the coefficients for each power. So like think about, go back to what we did on the first. X plus y to the 0. Did we just get 1 out of that?
Yeah.
Because I had to do 4 plus 6 and 6 plus 4, right? And just to answer this question for you before you ask, no, you cannot write this out to use on your test beforehand because you can just make it, right? It doesn't take that long to make it. I always say, can I write this out beforehand? No! Write it on the test. X plus y to the first is just 1x plus 1y. I'm not going to do all of these. But think about this one. X plus y to the third was x squared plus, x to the third plus 3x squared y plus 3xy squared plus y to the third. So if you just figure out what row you're in, you just take those coefficients. You don't have to do the NCR anymore. Isn't that really cool? You seem unimpressed, but it's really cool. So like what would this be? This would be what power? The 6th power, right? Because you have to think about this is to the 0 power. So you have to count 0, 1, 2, 3, 4, 5. No, 5. You guys, we were wrong, weren't we? This is n equals 5. So if we did this to the 5th power, watch how quickly I could do this. X plus y to the 5th. The coefficients are 1, 5, 10, 10, 5, 1. Go all at once. But x starts with n, and it just goes down by 1. So x to the 4th, x to the 3rd, x squared, and x. The y you can start this way and count back, or I just always start here. No y plus 1y plus 2 y's, 3 y's, 4 y's, 5 y's. I just did x plus y to the 5th in about 10 seconds.
They all need y's except for the first, right?
They all what?
They all need y's except for the first.
Yes. The first one doesn't have a y, the last one doesn't have an x.
Did all the way to 10.
Perfect.
So
Probably not going to get to that. So let's actually do this without x's, just x's and y's. What if we threw other numbers in there, right? Let's go. I kind of wrote these steps. I don't know if they're really necessary. I'm a steps kind of person. If needed, put in general form. That means sometimes it's kind of weird. It looks different. But for the most part, it should be written in like x plus y form. Sometimes they throw you off and they put the y first and the x second. That's okay. Y can be the first number. It doesn't even have to be x and y. It could be a and b. But it just needs to be a binomial. When it says expand on your homework, you can do the binomial theorem, which is the NCR stuff, type in your calculator, or you can use Pascal's triangle. So I'm going to put NCR or Pascal. But instead of just having x's and y's, you have to actually plug in the numbers that you need here. And I'm going to show you how I do it, and then if you want to skip a step, which you tend to want to do, then you can do that also. So I'm going to do the triangle way. You tell me if you want to do the other way. But when I see 4th power, I know I need the 5th row. There's always one extra term from what it is, so you need 5 terms. So very quickly, I can say 1, 1, 1, 1, 2, 1, 1, 3, 3, 1,
Wait, is
1.
first row 0 is first row 1?
First row 0. 4, 6, 4, 1.
5. 1, 5, 10, 5.
It's easy to remember if you remember there's always one more term. So if you need the 4th, you need the one that has 5 numbers in it.
It's 4th row.
Oh, that's the 5th row.
But you said row, the top one's 0.
But that's row.
That's why I just asked it is top one row 0 and you said yes.
Yes.
So then the next 1, 1 is row 1.
Yes.
That's row 4.
It
I'm so confused.
just depends on how you think of it. It's really the 5th one, but if you count row 1 as row 0, then it's the 4th one,
Okay, so it's just,
right?
it's the one with
So
the term.
let's just do this. N equals 0, n equals 1, n equals 2, n equals 3, n equals 4. That's how I think of it, Grady. You're right.
It makes sense now. I was just
But one more with 5 terms. And so just like I just did before, I don't know what makes more sense to you, to put the letters in first, put the numbers in first, to do it all at once. I don't know. But these are our coefficients. I don't have to do the combination on my calculator because I know those are my numbers. I know it's going to start with x to the 4th, and the x is going to go down as the y goes up. And so it's up to you on how this works for you. But I can do it all at once if you want me to. I can say then the 4 goes next, the x goes down by 1, and now I have a y. Because remember, every time it has to add up to n, so it has to add up to 4. So I know that that's right. Then I can say 6, because that's the next coefficient. And if the x goes down by 1, then now I need 2 y's, because that adds up to 4. And then 4, x goes down by 1, y goes up by 1, still adds up to 4. And then the last one is y to the 4th. And yes, it's okay if you put 1 y to the 4th, but I'm just not going to. Yes? I'm not done yet, though, because I always do x's and y's. If you want to automatically plug in those numbers over there, you can. For me, I always just do this first, and then I go back and I plug in if I need to plug in. If this is still x, do I need to change the x in this problem? No. But this is x plus y. Y is now -3, so I need to actually go through, and everywhere I see a y, I'm going to put in a -3. you would rather just do that to begin with, by all means, you're welcome to. It just helps me to do the pattern first, and then I plug my numbers in. And I'm actually going to show a good amount of work on this one just because it's our first one in our notes. Like, I'm okay if you didn't show this step on your homework. But I'm just replacing y with -3 because that's the second term in there. Did I do something wrong? I don't know, because I just wrote a 3 instead of 4. Gotta keep it straight here. And now I just multiply it out, and this would be if I took x minus 3 to the 4th power, I would get x to the 4th, 4 times -3 is -12, x to the 3rd, -3 squared is 9, times 6, 54x squared, -27 times 4, -108. And -3 to the 4th is 81, I think, right? So this is kind of a very quick way of doing this, right? Do you agree with that? It's much faster to do it that way. Still work.
How would you do it? Do I need to do the NCR one at a time?
You would have to do for each one of these. Well, to me, if I was going to do NCR, I wouldn't do it for these terms because remember, it's always 1 and n, right? So you'd only have to do it for this one, which would be 4 choose 2 because 4 is the n, the r is whatever the power is on the y. So you could still go through, and there's only one you have to do there, which might be just as fast as doing Pascal's triangle. Other questions on that? Let's do it out. There's some on your homework that are just letters, which means you just get to use the Pascal triangle formula. The ones with numbers shouldn't be to too big of powers because it's more of the process than trying to make you do a problem that has like 37 terms, right? That would be ridiculous. But if this is the 3rd power, I need the row with 4 terms in it. All right, you multiply now. I'll do it this way. So this is what I'm going to use. And again, if you were using the NCR stuff on this one, you don't even have to do it because it's just the first and last terms are always 1, the middle terms are n. There's not even an extra term in the middle that you would have to do a combination on. So again, it's about the process, knowing that you start with x to the n, and you use your coefficients, and x goes down by 1 as y goes up by 1. Very easy to check that each of your terms have a sum of 3 in the exponents. But again, how is this different than the last one? Is we have to plug in for both x and y. So I always make x the first term and y the second term. So now my x is 5. Sorry, I was going to write x there. And my y term is -3y. So the y is still going to stay in there, but I also have to put a -3 in there. So this is now my y term. Watch your signs as you do this, especially with the negative in there. That's why I think it's not such a bad idea to actually show me the step that you plug stuff in the right way, and then if you made a mistake, it's just a multiplying mistake. 5 to the 3rd is 125. This one's going to be negative 25 times 9 is 225. Is that true? Don't forget the y. This one is 9 times 3 is 27 times 5 is, I don't know. This is a negative 27y to the third. Ready? Don't sit there all smug that you got done before me because I was teaching at the same time.
Oh, you said, you went act like it's a race. I put mine in order.
You can switch it around. That's great. Questions about that? Maybe I'll get something crazy to you on like a fractional exponent or a radical. That would be cool, right? Right.
Terrible.
So I always use Pascal's triangle except for something like this, all right? So for me, if it said find the indicated term, that means they just want the fifth term of that. To me, Pascal's triangle seems like a whole lot of work because one, I need the one with 10 numbers. Grady already wrote it out, but on a test, you'd have to write it out to 10 terms, which you could. But I want to show you how to do it using the NCR stuff, okay? So remember that we wrote this out. If you had x plus y to the n, then any term there is n choose r, x to the n minus r, y to the r. There probably is someone with a tattoo of that.
What would you do to like make it cover up your expense?
I don't think someone in high school is going to get a tattoo of Pascal's triangle.
What would happen? Theoretically speaking.
Theoretically speaking,
Steven says don't challenge me.
they would have to cover it up for a test.
Like there's like on their face.
Well, then how are they going to see it?
But it wouldn't help them, it would only help other people. I almost spit my coffee out just so you guys are here.
You don't have to cover their face for the test.
I almost spit my coffee out. You guys are ridiculous.
Good call, man.
You just put like a hair like right here.
You guys are
The
ridiculous.
link is so
My husband worked with a guy at Home Depot that had a pi symbol on his arm, but he had a bunch of stuff on his arm, so he had to kind of look closely to find it. But
That's weird. Just look at the dude's arm.
Miss Dowd has the chemistry little tattoo, right? I couldn't do it. I love math, but I'm not gonna do the math.
It's,
I can't do it.
yeah, quadratic formula.
Oh, kids. So
Didn't get my joke.
the hard part about this is if it's the fifth term, what is n and what is r? Well, n is easy, right? N is always that number, so n is 9. A couple ways we could think about this. We could try to think about what is the power on r on the fifth term, or think about what is the power on the x on the fifth term. I don't know. How do you want to think about it? Maybe you just know. Oliviero says 4. Do you agree with him?
Remember I can
What is article 4?
What do you know?
Is the first term going to be x to the 9th?
Yes.
Then it would go x to the 8th, y to the 1st, right? So very quickly, could we say that the fifth term is going to be 9, 8, 7, 6, 5, right? So the power on x is going to be what this is. The fifth term is going to be the power on x. Yes? So the power on y is always going to be this minus this. What?
I did it easier.
What did you do?
Every y power is the number of the term. Q power.
Every y power is the number of the term minus 1.
Zero is a theorem. I just put that forward. Keep that 6 hours.
It's true. I always have just taken this minus this, but you're right. I don't actually write this.
This isn't a legacy.
He is legacy. If you know what n and r are, it's so fun to say that. If you know that, then you just plug it in the formula, all right? So that's where, once you know the trick, that is really easy to do, even easier now thanks to Oliviero. R is always 1 less than the term, always. So if it's the 7th term, R is 6. If it's the 25th term, R is 24. Because the y always is 1 less than the term, because it starts with y to the 0.
Spoiler alert.
Can you shut shut your mouth.
What'd you say? It's 126.
No, no, it's not 126.
Saying that that first part is.
Because if I want you to find the fifth term, I want the whole term. Okay, I want the whole thing, not just the 9 choose 4. I want you to plug in this and plug in this and work it out. So we can do 9 choose 4, which was what? 126. But then we also have to think about that x is 2x to the fifth, and y is just 1 to the fourth.
And that's because that's the fifth term.
Because that's what the fifth term would be if we worked it out. And so 2 to the fifth is 32, and then 32 times 126 is 4,032 x to the fifth, which means that's a really, really big one to work out.
After the fourth. Like 1 to the fourth.
What is 1 to the fourth? Just one.
I don't know about it, but why is it this?
It's just times 1, so it's just like, right? Like I can take 126 times 2 to the fifth times 1 to the fourth. It's still just 4,032.
Why does it say n minus r in the equation?
That's just the term of x, right? It's always going to be, it's just weird. I don't know why it just doesn't say to the, and yeah, but it's just the formula. All right, let's do another one of these. I don't know. Ask Liviero.
I hope it's actually the last one. I think you're right.
What's the essence of it? I mean, Olivia, you're my only daughter who speaks Italian.
So, n is this
What is
7.
C. It's C.
Oh, baby.
You have you telling Dylan to shut his mouth on the recording.
I'm okay with that. It was jokingly.
Now you say that. You're on record. My feelings are hurt.
Mr. Marquez says you always have to think about what you say to students and how it would look in writing. And let me tell you, I think I'd be fired from the things I say to students. So.
Or something
How it would look in writing.
like
Or if you just wanted me.
What if you like students in chokeholds and wrestling moves
Right.
in front of the classroom?
That's true. Not lying. So R equals 2. And if you know that, then very easily we can say it's 7 choose 2 x to the third y to the no, I screwed that up.
Yes, you did. Where'd you get that?
What's n minus r for?
I'll take over.
X to the fifth, right? Y to the second. Because it has to add up to 7, right? So if the power on y is 2, then this has to be 7 minus 2. That's where the n minus r came from. She did 7 minus 2 on her calculator.
No, she did 7 choose 4.
Oh, 7 choose 2 is what?
21?
And then x is just x, so that's going to stay x to the fifth. But y is negative 10z squared. So the actual term here would be negative 10 squared is 100. 100 times 21 is 2100. X to the fifth z squared. That is the only place I ever use the n choose r. Could you just do Pascal's triangle? You could. I just think that's a quicker way of doing it. What, Zane? Say that a little?
I like that every single time we do a different one. Like, I think this. Yeah, I've said it every single
It's a different type of problem.
This is a fast.
Here's the difference. Listen, it's the best way for that type of problem. If I said expand this whole thing, I would use Pascal's triangle. If I said find the third term, I would use n choose r. Those are the two ways, and I would do each one a different way. You have to choose the best one for that type of problem.
Credit though, we have set up that.
Oh.
Oh, not doing it.
What if I did this?
I don't have
Send it back.
This looks exciting, right?
Dysfunctional. Yeah, return it. We filed for an Italian.
Stop.
Dysfunctional.
Put it in
side of paper?
Yeah.
Oh my goodness.
I just use the front side. The base is closer to the triangle.
I wish we could have like board races to do this like the 20th hour. I would be so excited.
Put two people in there.
You said be so excited.
I love board races.
That's awesome.
You could get over there.
We're getting straight
I almost thought you used to ignore it. I don't know why.
So, this is exactly what we've been doing. I just threw a square root in there because I don't want you giving me decimal answers with the square root or fractional exponents. I'll put some fractional exponents in there. Which means you have to think sometimes of how to simplify a square root. If you can't simplify it, then just leave it as a square root. Alright? So, I would say 5 to the 4th plus 4 times 5 to the 3rd times the negative square root of 3 plus 6 times 5 squared times negative square root of 3 squared plus 4 times 5 times negative square root of 3 to the 3rd plus negative square root of 3 to the 4th.
What's next? That was the last. Negative square root of 3.
Not square root of negative 3, negative square root of 3.
Plus.
Have one of them fancy calculators. It simplifies square roots for you. I'm not a big fan of those. But,
You have two boxes of things.
no, it doesn't simplify square roots. Those don't. That's fancy. This, square root of 3. I can't do anything with that square root of 3, which means it's just going to have a square root of 3 in the problem. 5 to the 3rd is 125 times 4 times a negative, which means that's a negative, right?
It's like 475.
500? I got 500.
Probably is 500.
And I'm just going to put minus 500 square root of 3. Don't give me a decimal. I will put a red line through it and a frowny face. But what about this one? What is negative square root of 3 squared?
Negative 9.
Negative 3.
Oh, guys. Again.
I think it's just negative 3.
I think it's positive 3.
Which is
Oh.
Because a negative squared is positive, and square root of 3 times square root of 3 is really just 3.
Okay.
wait, the negative what?
The negative squared is a positive.
I get it. It's just
That's
3.
it.
So I think that's 450.
Times 3.
No, not times 3. I already did the times 3. I did 6 times 5 squared times 3.
You gotta say that out loud.
What about this one? First of all, I'm going to go ahead and say it's a negative because I know it's to the 3rd power, so I have a negative left over. If I take the square root of 3 to the 3rd on my calculator, unless I have a fancy calculator,
Say like that.
it's going to give me a decimal. I don't want a decimal. I want you to simplify it. Could you write this and think about it as the square root of 3 times the square root of 3 times the square root of 3?
Yeah.
So I could put two of them together just like over there, right?
Well, I would
So I could say that that's just the square root of 9, which is 3, with an extra square root of 3 left over. 20 times 3 is 60. I already took care of the negative, so I didn't have to think about it. And I have an extra radical 3 left over. And what about this?
9.
Negative square root of 3 to the 4th is going to be positive because to the 4th power. And this is like 2 sets of square root of 3 squared, right? So it's like 3 times 3, which I agree is 9.
Wait, why is it not 9?
It is 9.
Not 9. Why is it 9?
The square root of 3 squared is 3.
What's like square root of 3 times the square root of 3 was 9, and then another set would be another.
It would be the square root of 9 times the square root of 9. Right?
That would be square root of 81, and that would be 9.
Okay. As long as it makes sense.
Oh,
Look what's really cool about this. Do I have like terms I can put together?
No.
Oh my gosh. 625 plus 450 plus 9. 75 plus 9.
1,084.
And since both of these have a radical 3 and they're both negative, that's just going to be minus 560 radical 3. How much fun was that?
Not at Olivia, what are you doing that homework? Cheapest homework ever.
We say $5.
Yeah.
Yes.
Dude,
He's gonna do his own homework anyway, so that's really a, you know.
I'll pay you $5 too.
Oh my goodness, Shelby. Stop paying Olivia.
No,
I'll know he did it because he writes very different than you.
no,
Yeah,
I
you just write out and write out every paper.
That's really cheap then, because you just do your own homework and then they copy it.
Okay, good
The
point.
point is,
$2.50.
the point is, I almost never do my homework. Close your eyes and you still caught it.
The directions on the homework, some of them say use the binomial theorem, some of them say use Pascal's triangle. You can use whichever way you want, except for copying Olivier's homework.
You gotta stop recording.
Copying Olivier's homework. So if you want to use Pascal's triangle on the whole thing, you want to use the binomial theorem on the whole thing, I don't care.
Keep going.